session, we have amidst us Dr. S.K. Goyal. He is presently Chief Scientist and Head of CSIR NEERI Zonal Center at Delhi. He has done Masters in Chemical Engineering with specialization in industrial pollution abatement from IIT Roorkee and PhD in Environmental Science and Technology from Nagpur University. He has more than 100 research publications in journal and conferences and has supervised more than 30 MSc and Tech students and supervising 5 PhD students on air and water related topics. Dr. Goyal is presently working on various projects related to air and water pollution issues of Delhi NCR. He is former member of Expert Appraisal Committee EAC of MOEF NCC, member of Technical Committee of QCI and NABET, board member of Quality Council of India QCI, member of Subcommittee of Commission of Air Quality Management in Delhi and adjoining areas on monitoring and identification. He is also member of BIS on air quality. Goyal sir's achievement list is too long. With the time constraint, we cannot read it completely. So just summarizing it, I wind up with my introduction, and I now request Dr. S.K. Goyal sir to kindly take over and enlighten all of us by sharing his knowledge. Thank you, sir.
So thank you, Ms. Neetu, and thank you, Dr. Praveen Meshram, for inviting me and giving this opportunity to share my views on this very important aspect of air pollution, climate change, and sustainable development. And many of you might be knowing also. So I'll start with a brief presentation. Just allow me to share my presentation. You have to allow it actually, ma'am. Is it visible? Is the presentation visible?
Yes, sir. Yes, sir. Please continue.
Yes, sir. Yes.
Okay.
Yes, sir.
Okay, thank you. So, as you know, the theme of the entire training program is on the understanding various aspects of pollution prevention to attain the goal of sustainability. And the specific topic for today's lecture is air pollution, climate change, and sustainable development. So, as I understand the background of different participants, all are of basically faculty in different institutes dealing with different subjects of environmental science, life sciences, as well as chemical sciences. So I'm sure that all of you are aware of the basic aspects or basic things about the environment, and then where we now need to take it further. That is the big question. And as we know that the air pollution is now has become a very important issue almost in the entire country. So basically my presentation will be covered on the following aspects: air pollution issues and the city specific air pollution management plans, then air pollution hotspot identification and location specific air pollution management, and climate change issues, need to develop carbon neutral regions, and what we need for our country. So that is very important aspect that we need to understand, that where we are leading to and as a society, and what we need to do as a academician, as a individual, and where do we lead our country towards a sustainable development. And I'll be speaking about 60 minutes and look forward for healthy interaction for about 30 minutes in this session. So as you know that the air pollution is known as the silent killer and is a major environmental risk of the health. And almost every year 17 million deaths are occurring due to the exposure of both outdoor and household air pollution in the form of strokes, heart diseases, lung cancer, and both chronic and acute respiratory diseases, including asthma. And this is the breakup of the how the worldwide the spread is taking place because of the air pollution, and you see most of the countries are exceeding the WHO standards, and life is reported to be shortened by 9 years due to air pollution. And 90% of the countries in the world are having the bad air quality. And out of the 7 million deaths that are occurring, 2 million are in Southeast Asia region, 2 million in West Pacific region, 1 million in Africa region, and so on. So you can see that this is a worldwide problem, but the severity may depend upon the country-specific conditions or the different geographical natures of the region. So air is the most precious resource for human survival, as we already know that how much we can sustain without air. Water, we understand that few hours, few days maybe. From food, without food, maybe few more days, but without air, no one can survive more than 5 minutes or so. So though air is abundantly available in the atmosphere, yet the presence of a very small fraction of certain toxic substances can make it unsuitable for breathing and can cause several adverse health impacts. So that small concentrations of particulate matter or certain gases like SO2, NO2 and carbon monoxide, etc., though their concentrations are in the form of microgram per meter cube. But even those small concentrations are very harmful for the health. So air quality has deteriorated throughout the country over the years, and northern India is severely affected, particularly during post-monsoon and winter seasons when PM2 levels become very high, 2.2 to 5 times the prescribed standards. And the prescribed standard for PM2.5 is 60 microgram per meter cube. That means the concentration becomes 120 to 300 microgram per meter cube, and that persists for the season. It is not 1 day or 2 days, but that persists for the entire season of post-monsoon and winter in the Delhi and the northern India region. The situation becomes really very difficult. So CPCB or MOEF has identified 122 non-attainment cities across 22 states and union territory in the country. And these cities have failed to meet the standards of PM10 for 5 consecutive years. That is 211 to 215. So based on that, the CPCB has identified, yes, these are the non-attainment cities where the pollution levels are consistently high, and action plan has to be prepared how to improve the air quality of these cities. So accordingly, MOEF has launched a national clean air program for the entire country with a target of reducing the PM2.5 and the PM10 concentrations of about 20 to 30% by 2024. And that certainly requires the support and effort of everybody, every stakeholder in mitigating the pollution levels. So the present talk will be, it is emphasizing on how we can deal with the aspects of industrial air pollution control, vehicular pollution control, what should be the management approach, and how we can develop the carbon neutral regions. That is the ultimately that we have to integrate the things now. We have to see the atmosphere in a holistic manner so that the entire region, the entire area is made the pollution free, or the air in that area becomes the breathable air, free from diseases. So as I said that the air pollution, the country scenario is that the 122 cities have been identified as the hotspot areas or the non-attainment cities where the air pollution levels of PM10 and PM2.5 are very high. And this is the typical problem of the country when the dust pollution is very high because of many reasons, because the soil, the condition of the soil, the industrial sources, the vehicular sources, the conditions of the road, various activities are taking place, and that all leads to the high concentration of the particulate matter. And there are many other aspects related to that this is one thing is that this is based on the old data set 211 to 215. So again, the data needs to be updated, and these cities are covered under National Air Quality Monitoring Program of CPCB, and this number could be more when we look for the other cities. The number could be much more, and these stations are mostly monitored by Pollution Control Board or a few academic and research institutes, where the observations are taken only twice a week. It is not a continuous data, but it is twice a week monitoring done by the manual monitoring methods. And many places limited our sampling. There are certain issues related to sampling also. And now the question is about the whether the site is representative of the air quality monitoring site or not. Like there are certain cities where only one or two monitoring stations are there, and based on the one or two monitoring stations, the city is identified as the non-attainment city. So these are the some critical issues which also needs to be looked into when we prepare a holistic management plan. That what are the regions that are making the city as a non-attainment city? What should be the approach? A comprehensive, a holistic approach needs to be taken. And this you can see on the left hand side the legends, where you can see the different colors are there. So the standard is 60 microgram per meter cube. You can see the most of the south region, South Indian cities are in the green zone. You can see the green dots here. So that means the concentrations are just above the standards, or they are within twice the standards. So most of the South Indian states and cities are having the better air quality as compared to the cities in the northern India, where it is 2 to 3 times higher, or at a few places it is 3 to 4 times higher. Now the ministry has come out with a national clean air program where very comprehensive action plans have been devised for each sector, for each activity that generates air pollution, and but that needs to be converted in terms of what is required for each city. So it is not a uniform medicine that it will work for all the cities. The same thing will work for all the cities. Now every city has to prepare their specific plan for their specific problems and needs. So that is very important, how to translate that the entire basic document, guidelines document, into the city specific programs that deals with the problem of the specific city. You can see the entire, what are the different cities. If you see that this is nearly 20 cities are there from the Maharashtra: Akola, Amravati, Aurangabad, Badlapur, Chandrapur, Jalgaon, Jalna, Kolhapur, Latur, Mumbai, Nagpur, Nashik, Navi Mumbai, Pune, Sangli, Solapur, Ulhasnagar. So, and one important aspect is the Maharashtra has very good air quality monitoring network also. So that is the reason that most of the places, now the thing is that we need to ensure that whether these air quality monitoring stations are adequately located at the right place, are they representative of the air pollution problem of the city, are they addressing, or are they representing the air pollution of the entire city, or there are some local sources which affect the air pollution or which are detected by the air quality monitoring stations. So one needs to understand whether the problem is of the entire city or it is of the certain area where the air quality monitoring is being done. So you will find that many places are not there, many cities are not there, which you think could be having a problem of air pollution, but many cities appears to be that अरे यहाँ पर भी pollution है क्या? So I mean, the situation is like that. So that means it depends upon what is being monitored, where it is being monitored, and how representative the site is. So now the basic question comes: what pollutes clean air? Now this is what we need to focus in any region. There are multiple sources. Industries are there, transportation activities are there, water bodies are there which sometimes generate the gases in terms of H2S, odor, ammonia. Agricultural activities are there, fire is taking place, dust from the soil, agricultural fields is coming. Lot of activities are taking place. Sometimes forest fire, commercial activities. So whatever activity is being done in any region, that may produce some sort of air pollution, and that air pollution, when it gets suspended into the atmosphere, that causes problem once it is exposed, the population is exposed to those levels. But once this goes to the atmosphere, the atmospheric reactions takes place. Sometimes the wind speed that takes pollution from one area to another area, how much dispersion can take place. If it is monsoon season, some and rainfall is there, rain is there, then some pollution will get deposited on the surface. So this is the entire ecosystem that needs to be studied, that what pollutes clean air and what happens to these pollutants and how these pollutants affect the human health. So if we look at any area, any urban area, what are the different type of sources? Vehicular sources that we all know, industries, domestic activities, cooking in the household. See what type of fuel is used, whether it is LPG, it is wood, or some other fuel is used. So what type of fuel is used? Road dust, whether the roads are appropriate or not. Lot of resuspension of road dust takes place. Then biomass or agricultural waste burning takes place. Hotels and restaurant, lot of coal, coke, or wood, etc. is burnt there. Crematorias, many crematoria uses wood or other materials. Construction and demolition waste, stubble burning, landfill site. Many sources of air pollution could be resulting from the different activities. So source contribution in a city or area depends on the activity level and local meteorological conditions from one source, from one area where the activity is taking place, how far it will be transported to the other area and can affect the other area. So you can see that this is kind of in the agricultural field in many part of the country. Once the agricultural activity is over, the farmers try to clean their field, they burn it. And in the northern region, particularly in Punjab, large scale stubble burning takes place in the month of October and November, and that creates a very unfavorable situation for the northern region, and because it transports to a larger distance in the northern region and becomes a major source of air pollution during post monsoon season. So what needs to be maintained is basically for clean air, as the standards have been identified. The basic parameters like sulfur dioxide, there are 12 parameters that have been notified by the government of India, MOEF and CPCB. Sulfur dioxide, what is the annual average concentration and 24-hour average concentration for almost every type of setup, industrial area, residential area, rural area, or any kind of setup. 50 is the annual average concentration and 80 is the 24-hourly average concentration. And for ecologically sensitive area like schools, hospitals, forest areas, the concentration is also 24-hour concentration is same, but annual average concentration is slightly stringent on that. So similarly for NO2, 24-hourly average concentration is 80 microgram per meter cube. And for particulate matter PM10, it is 100 microgram per meter cube. For PM2.5, 60 microgram per meter cube. Ozone 180. And the method of measurement, that is also a very important aspect. Using which method? Because every method has its own sensitivity and the capability to detect to the concentration level, accurate concentration level. So using these method, a complete guideline is available that what should be the procedure for monitoring these pollutants, and if those guidelines are followed, then this should be the standards would be the applicable. Now there are 12 parameters. I am not taking all the parameters here. You know that other parameters are ammonia is there, and other metals. 4 metals are there. So now what needs to be controlled? Now we know the air pollution problem is there. Sources of air pollution are known. Parameters are known, and how they behave in the atmosphere, this is also known. So now what needs to be controlled? The sources, the pollutants, the activities. So depending upon what is the type of source, what is the type of activity, what is the type of pollutant, the action plan has to be prepared. Like the natural sources are there, we hardly can do anything about the natural sources, but certainly the activities which are created by man can be controlled, like the industries, like the vehicular pollution, the other activities. And the best strategy is that the control at the source. From this control at the source means where it is generated. the pollutant where it is generated. The second is once the pollutant is generated from the source, then it travels to the as per the meteorological conditions of that area to the different places. Then how it can in between it can be captured. Can it be? And the third is you have to protect the receptor. If there are certain sensitive locations that needs to be protected, for example, Taj Mahal, for example, your some hospital is there, for example, Victoria Memorial is there, or any sensitive receptor, one can say that this is the sensitive receptor from the air pollution point of view and needs to be protected. Then what should be the management plan for the protection of any specific receptor? So, and then how do it is to be controlled between the source and the receptor? What could be the mechanism? So best is control at the source from where it is generating, how best it can be minimized at the source. So the approach could be multidimensional, that can there be modification in the process from where the source pollution is getting generated, and how it can be reduced, how it can be minimized so that the generation becomes less. Secondly, can it be through some control system? There are several air pollution control systems are there, like bag filters, chambers are there, electrostatic precipitators are there, venturi scrubbers are there. So that kind of control systems, can these be used for a specific problem by any specific industry? What kind of vehicular pollution control measures could be there? Like adulteration is also one of the major problem that many times you see in the particularly in the commercial vehicles, autos, or maybe sometimes mostly in autos. I would not say other vehicles, but mostly in autos. Sometimes kerosene or adulteration also takes place, and how to prevent that, how to prevent them and reduce it. So these are the measures that one need to take depending upon the type of problem and the focus of the pollutant. Are we focusing only on the particulate matter, or the sulfur dioxide, or the carbon dioxide, or the greenhouse gases, and how they behave into the atmosphere? So what is our focus of the in any area? What is the problems, and that what needs specific answer needs to be looked for. So in order to prepare a comprehensive approach for air pollution management, what is done in a ES study when we drive the air pollution management approach for any city, then what is the approach adopted? I'm just trying to explain through this. The ambient air quality, what are the different uh, pollutant levels in a city at different locations in the city. For example, if we talk about Nagpur, then how many stations should be there where the air quality monitoring would be done with respect to different parameters, the general parameters or the criteria parameters like SPM, PM10, PM2.5, SO2, NO2, carbon monoxide, ozone, like the 12 parameters given in the notification. Then methane, hydrocarbon, total benzene, polyaromatic hydrocarbons, metals. So what is the air quality in terms of the entire? So that will identify what kind of sources are there and how much damage they can cause to the public. The second is the emission inventory and the dispersion modeling. And what are the different sources in terms of industries, major industries, small scale industries, middle scale industries, all the type of industries, what is their processes, how much emission is being generated from each type of industry from each locality, that all needs to be accounted. If from where, what is coming from where, how much pollution is getting generated from where. Similarly, for the vehicular sources, what is the vehicle movement on different roads in the area, what are the different type of fuel used by the vehicles, what is the age of the vehicle, what is the vehicle technology. So all those information needs to be accounted. And then what is not covered in the industries and vehicles, the rest is taken as the area sources. What is the fuel, the quantity of fuel, the emissions from the fuel, from the domestic activities and other activities in any area. All this emission inventory, that is that quantification of all the air pollution sources is done, which is classified into the broad category of these three broad categories. So how much total air pollution is being generated in the area, and then using the appropriate model that we call as a dispersion model, then how much what will be the impact of these emission sources on the air quality. How much air quality will be affected from the different sources, where it will have the impact of the air quality, that all will be assessed through this modeling exercise. The other is the source apportionment analysis, where the particulate matter that has been determined, the chemical characterization has been done in the terms of metals and different constituents, what the particulate matter contains. So it is not only first is the particulate matter on the filter paper, then what is it contains in terms of organic ions, inorganic contents, and then metals, ECOC, electrical, elemental carbon, organic carbon. All those parameters are characterized, and then based on that, what could be the possible sources in any region that is identified. So these three things are taken into account to prepare a holistic plan that what should be the air pollution management plan for any city. So this identifies the magnitude of air pollution problem and sources that needs to be tackled. And then this is how the air pollution management plan is to be prepared, that if the air quality is to be improved by 20%, 30% or 50%, what amount of efforts and where this effort should go, that decides. So what type of emission generation reduction preventive measures should be taken, or the curative measures should be taken. Preventive measures means that if you can modify the process where the emission generation can be reduced, that the air pollution source does not contribute, some process modification is done to contain the air pollution. Otherwise, some pollution control system has to be applied. So this is the holistic program that what needs to be taken into account to develop a air quality management plan for any city, and to further continuously updating it or reviewing its improvement, whether it is how it is being improving or not improving, what additional measures are to be taken, and we take the help of the modeling tool to assess whether this improvement is taking place or not, because in that the emission inventory plays a very important role. And if the emission inventory is done very comprehensively, very systematically, then you can use the appropriate model and see that what improvement for a given situation is taking place. So emission inventory is one very important aspect. And then once the emission inventory is prepared, you can play with the different meteorological conditions in different weeks, different months, different seasons, different years. So that meteorology, different scenarios can be prepared, that under different conditions of meteorological conditions, what will be the likely air quality in any region, and then how this air quality goals can be achieved, the 20%, 30%, what additional control or management strategies are to be adopted, that decides. So it is very important to prepare the emission inventory for any region, for any city, that what are the emission sources, industries, and where the control should take place. Now coming to the second part of my talk, that air pollution hotspot identification for effective management of air quality. So many prescriptions, so many tools, techniques are there, but often we find that despite best efforts of the various agencies, the things are not improving. Then what is the problem? Where the problem lies? And we tried to analyze the situation in Delhi kind of situation, and we found that, you see here, the most polluted area and the least polluted area, or the second least polluted area, are within the close proximity. You can see the blurring here. So how it can be possible that the most polluted area with the 524 air quality index value and the least polluted area of 220 can be so close, and they are hardly 3 kilometers from each other? That means the problems are not widespread in the entire Delhi. If the location is if this is taken as a one of the location, and based on this, if the entire Delhi is, or the entire city is declared as a non-attainment city, then the scenario is different. But if someone is taking the other air quality monitoring station, then it becomes a very less polluted air quality monitoring stations, and this will not be a non-attainment city. So that kind of variation could be there even within the very close proximity of 3 to 4 kilometer area. And why there are so much variation in air quality? That means there are some local sources which are influencing the air pollution at each and every location. So that means that in the another example, I'll show you another date after 2 years of that, even most polluted area, least polluted area, they are occurring somewhere in the similar area within 5 kilometer area. So that means when we are talking of the city specific air pollution management plan, even this requires a area specific, location specific air quality management plan. So it is not that whatever the plan is made for the entire city, so it helps the improvement in the entire city. So one has to be careful again that this may be requiring a further detailing micro level planning for each area, for each colony, like what are the type of sources where the pollution is levels are getting higher, what is the measurement technique, everything that leads to very comprehensive analysis of the situation, that why it is happening so and how best it can be tackled. So you can see here that how within a close proximity of 5 kilometer area, the most polluted and the least pollutant area are taking place. So here the question arises whether it has been correctly identified as the hot spot or the area of concern. That so when we try to analyze that air quality monitoring station where the air quality monitoring is taking place, then first important thing is aspect what are the different sources available within that immediate vicinity of the any air quality monitoring station, say half a kilometer or 1 kilometer area. So what are the different sources, pollution sources are there within the close proximity of the air quality monitoring stations, because this pollution from these activities can reach to the this air quality monitoring station and represent the air quality of this area. So even within 1 kilometer area, you can see one of the location in Delhi that how many sources, it looks very highly congested or constructed area where there are two nearby bus stands are there, where a lot of movement of buses takes place. Uh, uh, Kacha parking place is there, playground is there, domestic activities are there. So obviously the activities taking place within this area will generate the air pollution and they will be getting reflected in the air quality monitoring station. So that means if you have to prepare the control action plan, then the control action plan first has to be implemented in this area within half a kilometer, within 1 kilometer, and then go beyond. So once you see the what is implementable within this small area, and once that is implemented, is there an improvement or not improvement? How much implementation could be possible? So that all can be done or checked through modeling exercise also. Once a good emission inventory is prepared for such kind of area, then with the help of the modeling, one can determine what could be the likely improvement in air quality. And once that those plans are implemented in this area, then one can think beyond. Yes, now this is how much 20-30% is done by making the implementable plan in this area, then the other region needs to be taken care. And we analyze the area. You see here that nearly 73% of the area is a built up area of this. So that means the most of the area, 70% is the built up area, 15% is the barren land, and only 12% vegetation. So that means once the air pollution comes from the different sources, it has very less scope for getting captured through the vegetation. And then again, we try to analyze the Delhi has a very good network of air quality monitoring stations. It has 38 continuous ambient air quality monitoring stations located across Delhi in different locations, as you have seen in the previous picture also. So what we did is we tried to analyze the data for 3 years, for 2018, 19, 19, 20, 20, 21. And you can see the pattern here. Monthly data is analyzed here. You can see the pattern. Summer, the levels are slightly high. This is the data of PM 2.5. Monsoon, the levels are low, around 50 to 60, 70 in that range. And then suddenly in the post monsoon season, that is the October, November months, the values starts building up, and which again remains for some time in December, January. And then when the winter season starts going off, then the levels start come down. So two things, you can see the pattern is almost same in all the 3 years. So very interesting aspect that this pattern is very, very similar. So seasonal variation or monthly variation, the pattern is very similar in different years. But the only thing is that the difference between the air quality monitoring stations. So if you see here, the value in the lowest value in a month is about 120, and the highest value something about 300. So 2 to 5 times difference is there. Even within the same city, the difference is so much. So you can see that even among the different air quality monitoring sites, the difference in air quality, it could be very high. And this is very significant, particularly in the month of winter. Monsoon, it is more or less uniform. That difference between the two locations is not much. Summer, it is 40 to say 120. So again, 3 times difference is there. In summer, it is again 3 times. You can say, yes, it is the winter 3 times. So that much of variation can be there. That means anything that you are saying for the city, it is not applicable for the entire city. The air pollution is not applicable for the entire city. One has to identify the different pockets, different areas where the air pollution levels are high, and based on that, what corrective measures in the surrounding area of that air quality monitoring stations are to be taken. So that is very important aspect, that those who are associated with air pollution monitoring or air pollution management, they need to understand what is the basics problem of air pollution in any given area. So monitoring at few locations cannot be said that it is for the entire city. Depending upon the size of the city, more needs to be done to ascertain, yes, this is the very comprehensive analysis that establishes, yes, it is for the entire city. Otherwise, one has to be careful in selecting that this much of variation could be there at different locations, different areas, even in a city. 1, 2, 3. If someone is here, if you are there, 100 to 150 around, and some could be 300 during the same month. So such a huge variation is there. That means the strategy for this and the strategy for this cannot be same. That means there are some additional sources which needs to be taken care, and that is then only one can make an effective air quality monitoring program. So what we try to prepare is a hotspot identification criteria. When we say the hotspot, that means this is some area which is a critical from the air pollution point of view. Yes, that requires additional efforts. That requires additional efforts to control air pollution. That means consistently the pollution levels are high in that area, and that requires a special treatment for mitigation of air pollution sources, so that the air in that area becomes breathable. So again, one can say that 60 is the microgram per meter cube is the limit. Then what is the severity of the hotspot? So at different scales, 2 times, 3 times, 4 times higher. So different monitoring locations indicate the level of severity. What is the level of severity? It is more than 4 times in this area, 3 to 4 times in this area. So not the entire Delhi is having the problem, but the locations where it is monitored, this is the location most of the activities are taking place. So in summer, the problem is not that severe, but in winter the problem becomes very severe. So we have prepared a defined the criteria then when one should consider a monitoring station as a hotspot monitoring station, and what activities are required, control actions are to be taken around that location. So to summarize, so to prepare the clean air action plan for any city, for any area, hotspot area or the non-attainment city, there is huge variability among the different cities, among different localities or colonies, wards, air quality monitoring stations. So one needs to prepare very specific program, that which city is to be targeted, which areas to be targeted, which air quality monitoring stations, which parameters, which sources. So again, it is like there are multiple type of sources, multiple type of industries, which type of industry sectors. Because again, when we say the industry, it is a very broad term. Industry means it's a very broad term. It could be having large scale industries, medium scale industries, small scale industries. Again, in the industries there could be different type of industries. Again, in that the production patterns could be very different. So much variability is there in defining those parameters. So then what parameter we are, when we say the air pollution, the problem of air pollution, the air pollution is because of what? Air pollution is because of dust, PM10, PM2.5, SO2, NO2, carbon monoxide, ozone. Which pollutant? The air pollution is different seasons. Is it uniform? As you have seen in the previous slide also, it varies significantly from season to season. So which season the problem is very severe, which season it is okay, then accordingly the air pollution action plan has to be prepared. And the basic 3 steps are there: control at the source, between source and receptor. If there are certain important receptors, then from how to protect those receptors or important places, locations, and then in between. And this requires, of course, a huge amount of funds and time and willingness and commitment to do that. Air quality improvement has to be done for the entire city. So again, how to derive the specific action plans? It has to be the quantification or the emission inventory of all the sources. What is the likely impacts on the human health, on the economy, and what are the different routes, and then improve understanding, enhance capabilities, and implement for better air quality in an area. Then one has to prepare those who are responsible for making the air quality improvement plan for the area. They have to take into account all these aspects for improving the air quality in that area. So to summarize, I would say that each city, each region are not similar. So it is not copy paste kind of situation. One has to prepare, one has to analyze the situation of each city, each region, and accordingly this city specific, region specific mitigation strategies needs to be formulated. सबको एक दवाई नहीं चलेगी. It has to be prepared the patient specific, region specific, area specific, city specific. Then need simplified approach, because this is the problem that require the inputs or the support of everybody. When there are problem is of that magnitude, whether it is vehicular, industries, the approach has to be very simple, which can be easily understood by everybody and easily implementable by everyone. Then as the city grows, the time over the years the situations change. Then how to account for the changing local developmental strategies? Like metro was not there earlier in Nagpur, now metro has come. Roads have been very good roads have been created. Then how to account for that needs to be accounted, rather that needs to be accounted in this process, that how these developmental activities are taking place and how they are going to improve or deteriorate the quality of the air. Set sector-wise smart goals in holistic manner to achieve sustained improvement in targeted time. That is very important aspect. Otherwise, some activities are started and without any having the goal or the set time targets, that the activity has been initiated, but it does not have any end. So that whosoever is engaged in the preparing the any master plan or action plan or have the responsibility of this implementation of that, they have to keep certain smart goals in mind so that the activities are completed in time, and need to work fast, because now the level of understanding, level of knowledge sharing, knowledge information available is very good through the social media, through the so that earlier it used to take a lot of time, but now everybody can be connected, can be communicated very fast. So now the time has come that we can work very fast on these issues, and need to create proper execution mechanism and ensure its effective implementation. So once the proper mechanism is made, I think it is very important to ensure that how this program, any program, is to be executed and how effective the implementation is. So the entire team has to work very effectively, very dedicatedly for the cause. So as far as air pollution is concerned, the key aspects that I would say is the proper diagnosis for understanding of air pollution issues or hotspot is very important. What is the problem, whether the problem is real problem, what is the magnitude of problem, it is a consistent problem, whether it is a throughout the year the problem persists, or it is during certain only certain seasons, certain months it is there. For example, if you see any traffic intersection, busy traffic intersection, the carbon monoxide and NOx levels could be very high. But and that too, is it 24 hours? No, it is during the peak hours, isn't it? So that means the correct or the proper diagnosis of the problem is very important to understand. Then accordingly, one has to prepare the action plan. Then identification of visible sources, and which are very known, which are very obvious problems are there. So can we, in the first phase or the immediately, can those kind of problems can be sorted out, visible sources, visible, which are very common, so that can be taken care for those kind of things. Very sophisticated measurement or instruments are not required, which can be done only by the then quantification of possible emission source contribution. Then once that visible sources are taken care, what is the next level of emission sources that are contributing, then prepare appropriate control strategy for each source, whether it is industry, vehicular problem is there. So if it is a traffic problem in the traffic junction or some localities are there, then first it is the traffic needs to be looked into, that what is the traffic, can it be diverted to some other place. So that can be, I mean, logically one can work out that what could be the possible problem and possible solution also with the help of modeling. So monitoring, large scale monitoring is not required in such cases, and then implementation with continuous monitoring of effectiveness. Even the whatever the efforts are being made, that needs to be monitored on regular basis to see that the efforts made are really fruitful. Any question at this stage? Any question at this stage?
No, sir.
No, sir.
Okay, so then I'll go. Okay, then
No,
I'll go
sir.
to the next. Okay, then I'll go to the next part. So if you look at, as I have shown you one of the pictures earlier, we have to see the entire region. We have to see the entire region, your city, your area, your colony, where your campus. So whether that entire campus can be made as a carbon neutral region, carbon neutral area, or air pollution free area, then what it requires. So the effort should be that how that can be made as a zero air pollution activities, aiming towards zero air pollution activities. That means the air resource. So that air pollution, that the air available, that this is to be treated as a resource, not as a like freely available, abundantly freely available. Yes, it is there. It is nature's gift, and we are using it abundantly. But that small gift that keeps us, all of us, alive is very precious, very important for us, and that we need to uh, treat as a resource, a very precious resource for our survival. And if you know, as you know, that the what are the potential impacts of the climate change? I'll just quickly go through that. Now the impacts are very visible, and lot of efforts, lot of studies have been done. And what happens once this water level rise takes place, the temperature goes up, and even the 1 degree centigrade temperature, what havoc it can create. It is affecting the agricultural productivity, agricultural patterns, health, forest, water resources, coastal areas, natural habitats. A lot of adverse impacts are seen in terms of changes in the seasons, and once the changes in the seasons takes place, the entire ecosystem pattern that gets affected. And that means everything, right from the agricultural activities to different patterns, that all get shifted or changed. So that is, this is how that climate change is affecting the entire globe. And for that, the basic reason is the world population and the CO2, which is the main culprit, can be said as the culprit, but this is not the culprit. This is the aspect that we need to take care, that how the population has grown over 200 years, 250 years. Just you see on the left side how the population has grown, the world population has grown. It took from 1 billion to become 2 billion is 126 years. From 1 billion to 2 billion, it took 126 years. Then 2 to 3 billion, it took 33 years. Then 3 to 4, 4 to 5, it is taking only some 10 to 12 years now. And if that pattern continues, by 2021, by 2100, it will become 14 billion. And the area and mass of Earth will remain same. That is not going to enhance. Our resources, natural resources, will remain same. So whatever the pressure the Earth is facing now with the 7.5 billion population, what will happen? Just imagine what will happen when the population becomes 14, just double of it. So from where all these resources will come, and to make our life comfortable, what will happen to the carbon dioxide levels if the present rate of growth continues? So these are some of the predictions that how this from 1850 to 1958, increase in carbon dioxide was only 40 ppm in 108 years, and from 1958 to 2006, it is 48 years, it has increased by 55 ppm. That means 3 times increase, decadal increase. If you see, the 3 times increase has taken place. And if you see that for the whole century, so again the increase could be of the order of 40. That means again almost 3 times in this period. So if this rate of increase in carbon dioxide concentration continues to be there, then what will be the temperature rise and how will be the impact on the ecosystem or this earth? And it is very simply related to the population, and population is pollution, and again pollution is that any activity that we do will have impact on the air, atmosphere, water, and the waste. So climate change or global warming are independently related on the different sources. And the action point, then what is the action point? Action point is the individual, and that individual is individual industry, individual sector, individual organization, individual region, individual scale, individual as an individual, by you, by me, all those. So that we need to ensure that when we are talking of this sustainable development, how we can ensure that without compromising our requirement or the need, how efficiently we can use our resources optimally, how we can minimize the waste generation, how we can optimally use the resources so that minimum waste are generated. As far as the CO2 emissions are concerned, these are the major industrial sources which generate a huge amount of carbon dioxide emissions. Oil and gas, petrochemicals, power, chemical fertilizers, cement, steel, aluminum, transportation, pulp and paper, mining industries, metallurgical industries, and so many things. So how to remove the carbon dioxide from the atmosphere now? As the carbon dioxide levels goes up, the more and more, and the temperature will be more and more in the atmosphere. So can we think of many technologies are now coming up for capturing the carbon dioxide and using it for different purposes, making some chemicals also, and to what extent this can be done, how efficiently, how much it can be done, that is to be seen in the time to come. But certainly it requires a lot of efforts to ensure that this carbon dioxide is captured and utilized for the development of the region. One important thing is that once we say that the carbon dioxide level is that, do we have appropriate monitoring mechanism for that? What are the different carbon dioxide levels in the country in different regions? That needs to be incorporated. Or now this is to earlier, these two parameters, carbon dioxide and methane, these were not considered as the pollutant. These are not categorized as pollutant, but these are the natural outcome of any air pollution activity, any combustion process or anaerobic digestion. These are the natural outcome. So now these parameters also needs to be taken into as a pollutant, you can say. And as the country has made the commitment to become carbon neutral or net zero by 2070, and these are the major sectors where the carbon dioxide emissions are very high, that needs to focus on different major sectors. Energy, electricity, or this is the combustion process, basically the industries which are using lot of combustion fuel, those needs to be the highest contributor of carbon dioxide emissions. Then the agricultural activities and construction, transportation, industrial processes, so all this needs to be taken. That means it requires a huge effort from everybody, from the industries, from the even the common citizens, whosoever and whatever the contribution an individual can make, that needs to be made. So as an individual, if you look at what you and me can do, I'm just giving you an example that how much fuel is used by an individual. I tried to analyze my own data. I used a two-wheeler, how much kilometer is used in a year. In 2 different years, I did it, and how much four-wheeler was used and how much electricity consumption was done. And I tried to calculate in terms of carbon dioxide equivalent, and I found that in the 2 years it was more or less consistent. That means the activity patterns, the type of consumption, the type of contribution was all more or less same. And to the surprise that 47% of the contribution in terms of CO2 comes from the electricity consumption in the household. So this is not this is only the household electricity consumption. So when you are in the office, that is not taken into account, because on working days you are in the office, AC is there, lot of lights are there, so that is not accounted. It is purely on the domestic consumption from AC, from in the summer, from winter, in winter the geyser is there, or different appliances of electricity, all those contribute to as much as 47%. And then the transport, in terms of whether it is your own vehicle, two-wheeler or four-wheeler, or going by train or by flight for the official purposes or personal purposes. So that means the transportation is the next sector. If I take it, whether it is local or intercity transport, 47% comes out to be the electricity consumption, and then 43% of the transport. That means going out from your home and then doing your daily activities and then coming back. That means 43%. The second largest contribution is from the transport activities, and from the domestic other activities like the cooking, LPG consumption in cooking, and waste generation is only 10%. So these are the two major targets areas where one can optimize at how much electricity consumption can be reduced and how much fuel can be saved or the activity can be saved. That is another important focus area, that for an individual how we can optimize these two and how best we can contribute in. And national the national average is in 2010 was 1.3 million tons of carbon dioxide equivalent, and in 2019 it was 1.87, and I was having something about close to that. And what we can do is to reduce our carbon footprint or the so many things are there. We always on the environment day or any specific day we get lot of prescriptions that what we should do on reducing our carbon footprint or the things that we can do for the sustainability of the environment or sustainability of this. So I mean, one individual has to analyze their own things, that how best we can do, or the areas or their own influence zone, maybe in terms of students or something like that, that what can be improved. Energy efficiency of your home, can we have now low energy appliances are used, how this energy wastage can be minimized, are we using the even when it is not required, are we switching off. These are the simple measures, but one has to be careful. Food wastage, opt for local and sustainable production, travel by more sustainable means, whatever and wherever it is possible. It is not necessary that every time we should follow it strictly, but where and whatever is possible, one should do, make little contribution. And you may not experience the impact in larger terms, but you can, if you quantify yourself, yes, what reduction you have done. Like I have tried to analyze my own activity, how much I have traveled in terms of local travel, in terms of two-wheeler usage or four-wheeler usage, and what is the electricity consumption. So that way you can yourself can account, you can make your own charts that how much reduction you have done over the years. So this is a way of life that we can understand and try to make it, how we can make our lifestyle for change, like lifestyle for environment, how individually we can be more sustainable, the activity, our activities could be more sustainable towards in the life. Are we taking the bags for the vegetables or they taking the material from the market, how frequently. So these are the simple measures that we can take in our life, day-to-day life, and without accounting that somebody is going to check it, one has to check themselves. Yes, I'm trying to improve myself. So that kind of attitude has to be there, then only we can make a little bit impact. So now the next part is about the what we need for the country. As the country is entering into the Amrit Kal, or the and the very important message has been given, particularly from the environmental point of view, that the mission life, that mission life is the lifestyle for environment. So that means our lifestyle, and particularly the corona period has taught us the lesson that how much resources we really require, and how best what are the resources we require, how much is required, and how we should live even with the limited resources, how best we can live a good or healthy life to make our country as a Atmanirbhar Bharat. Can we make, and our little contributions, maybe when the faculty is there, they can teach their students how to make, and what effort should be there to make the country prosper and have the environmental adverse impacts to the minimum. And the one basic thing is there that the country needs to feed 140 crore population. That is a very well-known fact. And this population is going to increase again decade by decade. And I think in the next decade, it will become 150 crore and so on. And the country's boundary is constant. That is not going to change. And the resources are again not going to change. Again, we have to make that how sustainable the environment remains so that these are not affected, badly affected, so that the generations, present generation as well as the generation to come. That means the generation to come means when it becomes 140 crore to 150 crore, 150 crore to 60 crore, like that. So the population growth, continuous population growth, they also get sufficient amount of food, water, and the quality of air that it requires for a healthy living. And certainly this requires a very environmentally sustainable large-scale industrial and infrastructural development throughout the country, but in an environmentally sustainable manner to provide the respectable quality of life for the so much of population which is going to increase in the years to come. Every time the respectable quality of life is one of the key parameter that everybody wants or everybody deserves to have a respectable quality of life. And this requires efficient use of resources, various resources, irrespective of it is not air, water, it is every resource, even our own materialistic thing. Are we judicious about use of our own resources, materialistic things, as well as effective waste utilization? So what is waste? If we look for what is waste, hardly anything is waste on this earth. So it is a substance or the material which is not useful for any given purpose. But this is not waste. This can be used by other people, other person, other entity. Right. So need to adopt, as far as the waste is concerned, need to adopt circular economy approach. Now the earlier approach, I'm sure that you might have heard about the Life Mission Life, which the Prime Minister has encouraged, and almost every government department has its logo printed on their letterhead, and that basically provides a very comprehensive and holistic approach towards the life. And basic purpose of Mission Life is to bring individual behaviors at the forefront of the global climate change narrative. That means the individual has to improve their lifestyle pattern. And that lifestyle improvement in the lifestyle pattern means optimal utilization of resources, minimum waste generation. So these are the two key points imbibed in this, that how the individual behavior can be improved. And this is what is the corona has taught in those two critical periods. Life envisages replacing the prevalent use and dispose economy. Though some of the terms may appear to be very heavy to understand, but in the simple terms that we have adopted the approach of use and dispose, use and throw. But the use and throw approach means lot of waste is generated, very little is utilized. If you look at the basic raw material, very little is utilized and lot of waste is created. So how to convert that into again a resource with the help of circular economy, which would be defined by mindful and deliberate utilization. So that means very judicious, very deliberately how that waste material can be converted into products which are again brought back into the economy or for the utilization of the human beings. So that will help us in creating the pro-planet people. So that means we are the people who are practicing this at different stages will be they themselves can call as a pro-planet people. Yes, हम अपने धरती के लिए जिम्मेदार हैं, हम अपने ग्लोब के लिए जिम्मेदार हैं और हम उसको बड़ी जिम्मेदारी के साथ हम अपना ये कर्तव्य निभा रहे हैं कि यस वी आर एनवायरमेंट फ्रेंडली, वी आर प्रो-planet people. who will have a shared commitment to adopt and promote environment-friendly lifestyle. The purpose is to promote environmentally friendly lifestyles. That means environment friendly when we say that in all respect, how we are minimizing minimizing the use of resources, optimum utilization, and minimum waste generation, and utilization of the waste, even if it is waste, and how that waste can be utilized, and that leaves very little or very less for the nature to take care. Nature will take care, but it will take its own time. But how much it can be reduced, the pressure can be reduced on the nature. So this P3 community, that we say that those who are concerned about the environment, that our tradition, the Indian culture, the tradition has been always a pro-planet culture. Since ages, it was a pro-planet culture. The country had a pro-planet culture, and like we are worshipping our rivers, our trees, our animals, like that. So that means the country has imbibed the pro-planet culture itself, but in between somehow the track is lost. So that culture needs to be again revived, and it is to be integrated to make that this is a the place where we have to uh, uh, create an ecosystem that will reinforce and enable environmentally sustainable or environmentally friendly behavior to be self-sustainable. So that means the behavior, it is focusing mostly on the behaviors, our approach, our attitudes, our lifestyle on day-to-day basis. For example, nowadays you will find that use a lot of packaging materials are used. Anything you want, immediately you just uh, Zomato or Swiggy, you get the material, whether it is food material or any other item. With that, lot of packing material comes. Okay, then what to do with the packaging material? That goes a waste. How to utilize that? No value. So how it can be made again? So there, one has to devise their own techniques, that how I can make change in that, what can be done with this, so that kind of new things can emerge from this whole understanding. This is a simple diagram, the approach that what the earlier concept of linear economy was there. Take, make, use, and waste is generated because the population was less, and we can afford this. But now the time has come that we are not able to, we can adopt this approach. Now we have to go for this circular economy approach, where the waste is no more waste and it is a resource, and that resource has to be converted multiple times till it becomes a really a waste material that the nature will take care of it. It has to be used multiple times, and this is to be demonstrated through different regions, through different areas. It is not that the entire country or the entire state this kind of concept can be applied. Now the at the ministry level also, now the efforts are being made to convert the hazardous and toxic waste into some more useful products. Earlier it used to go to landfill sites, secured landfill sites, but now they are trying to recover the waste from recover the material from those hazardous waste also. Then how that hazardous waste can be recovered, water can be recovered from the hazardous waste, certain chemicals can be recovered and again brought back to the process. So if it can be done for the hazardous waste, why not for the non-hazardous waste? And packaging material is one of the examples. Just think and evaluate your own way, that how much packaging material you get in your house and what you do with that, and how you what you can do with that. Both the things are there. Your creativity can be an answer to that. What new things can be created out of that? So this is the example that how we can convert our waste into some products. So now, so the effort should be on that, generating less quantity of more quantity from less quantity of input materials for more people. So that the whole basic concept lies in this, in the process optimization, increasing the efficiency of the process, so that the less quantity of waste is generated. Waste, when we say waste, waste can be in terms of air waste, water waste, wastewater, solid waste affecting the atmosphere, water bodies, and the land, and that too if these are not meeting the discharge norms. And what part can be conserved, reused, or recycled in the process itself in the industry? Can part of it again be used as a raw material in the industry, this industry, or can there be some other industry which can recover these materials, and then another secondary economy can be generated from that? And what is the efficiency of the each industry or each process, so that from less quantity of raw material, more quantity of product can be generated, and which can be utilized for the more people or the more outcome. And then once the product is available, then how judiciously the products are utilized or the services are utilized. Just to give you an example of a power plant, to produce 1000 megawatt power plant, it requires nearly 12,000 tons of coal per day, water nearly 1 lakh million meter, 1 lakh meter cube per day, and in terms it generates 30,000 tons per day of CO2, 680 tons of SO2 and NO2, and the transmission losses. And it, so once this much of, and generates 4,200 tons per day ash. So you can see the time, the material which goes as waste: CO2, SO2, NO2, and ash. These are the three materials which go as waste, and how this can be further optimized. So in India, you see the transmission and distribution losses of electricity is more than 20%, whereas in the European countries and the Japan and Germany, these losses are of the order of 4% to 5%. So if even if we focus only on the improvement in terms of transmission and distribution losses, this will improve the performance over the requirement of the power. So that means from the same quantity of the input raw material, more quantity of more
कुछ प्रॉब्लम जा रहा है क्या?
शायद उनका कनेक्शन लॉस हो गया सर।
कनेक्शन लॉस? अच्छा अच्छा अच्छा। शैल वी वेट फॉर दिस?
यस यस।
ओके। Hello, participants. Am I audible to you? माझा आवाज येतोय का तुम्हाला?
Yes,
Yes,
sir.
sir.
Yes, sir.
ऍक्च्युली डॉक्टर गोयल सर हे दिल्लीच्या त्यांच्या झोनल लॅबोरेटरी मधून त्यांचं प्रेझेंटेशन देत होते, पण तिथे त्यांच्या डिव्हिजन मध्ये काहीतरी करंट गेला आहे म्हणतात. तर त्याच्यामुळे ते प्रेझेंटेशन थांबलेलं आहे. तर जस्ट विल वेट फॉर 5 to 10 minutes. इन केस जर करंट आला तर ही इज गोइंग टू कंटिन्यू. अदरवाइज वी विल रिक्वेस्ट हिम टू प्रेझेंट हिज प्रेझेंटेशन at our group, in our group. ठीक आहे?
Okay, sir.
Okay, sir.
5 मिनिटं थांबून जाऊ आपण.
Okay, sir.
आणि
Okay.
मग लगेच मी तुम्हाला सेमिनारच्या संबंधात काही इन्स्ट्रक्शन देणार आहे मी तुम्हाला आफ्टर हिज प्रेझेंटेशन.
Okay, sir.
हा, सकाळचं प्रेझेंटेशन आवडलं होतं का? बर्ड्स अँड वाईल्ड लाईफ बर्ड्स.
हेलो.
हॅलो.
हाँ मिश्रम जी, मैं जो ना मैं मोबाइल से कनेक्ट किया है मैंने अभी ये.
अच्छा
तो
सर, वेरी नाइस.
ऑलमोस्ट मैं आई वाज टुवर्ड्स द लास्ट स्लाइड ओनली.
ओके
तो
सर.
है ना, तो आई विल टॉक टू फ्रॉम द मोबाइल ओनली, नो प्रॉब्लम.
ओके सर, कोई प्रॉब्लम नहीं सर. यू कैन कंटिन्यू थ्रू मोबाइल ओनली.
Right. So the point was, I was telling that if you focus on, if you identify the problem and try to figure out what could be the possible solutions. So there is nothing to do with the power plant, but the problem lies in somewhere in the capturing the transmission and distribution losses. If we capture that, then certainly we can get the more output from the same amount of raw materials, from the same capacity of the industry. We can get more output. So that we have to find out what is the problem is there and where we have to tackle it. The secondly thing is that whatever the waste are generated, whether it is carbon dioxide, can there be now the lot of focus is there on the carbon capture and utilization and storage. So to what extent this carbon dioxide gas can be captured from 1000 megawatt is this 30,000 tons of carbon dioxide is getting, and also from the sulfur dioxide and nitrogen dioxide this can be converted in terms of some fertilizers. So these are the aspects I think this one can think of, and the upcoming research can be further done in this area. Can this be converted into some fertilizer? The huge raw material is there, huge resource is there, but how this resource to be utilized, that is the future that we have to again look into. The fly ash, it has multiple uses. It is now mostly used in the cement industries, and it has many applications. To what extent it can be again further used? So in last 30-40 years, I think we have seen earlier it used to be huge stocks near the power plant, but now most of the fly ash is being used in the cement power plant or other applications. Fly ash bricks are being made mandatory. Most of the flyovers are made from these fly ash bricks. Constructions, lot of construction activities are taking place from the use of fly ash. So that way, the waste which was considered as a waste one upon a time, now these are being used as a product, as a raw material, and now the various products are being made. So similarly, whatever being thought as a waste today can be the waste of can be the product of future's raw material resources. It requires the integration and creation of robust approach of the team of different faculty, I would say, to know when we are talking of environment, it requires the integration of different faculties, different strength from different groups, engineering, science, all stakeholders. Big team is required to deal with this kind of subject. Otherwise, only individuals will be working in small sections of that area. So it is not the chemistry, it requires chemistry, it requires environmental science, it requires life sciences, it requires engineering aspects. And of course, as the things get added up, it may require the other disciplines also. And maybe IT, computer science, like that. So the ultimate objective of all of us should be that how environmentally sustainable our activities are, so that we can live a healthy life with clean air in the atmosphere, in your area, in your district, in your region, and throughout the country. And this is all I wanted to say from my side. and I look forward for your questions, if any. So I'll be happy to respond to that. Yeah, Mishram ji.
Sir, I have one question, sir.
Yeah, please.
Sir, actually, you talked about the carbon capturing and utilization. How many plants are, how many units are here in India?
India,
I
as
think these.
yes. As far as I know, that recently one plant has come up in Singrauli, and NTPC Singrauli has already started on commercial scale. So this is a good
Okay, and sir,
initiative.
okay,
Yeah.
sir, yeah. And what we do the storage there?
So they are converting it into some chemicals. So more details are not available, but they are making some chemicals out of it.
Okay.
So
Yes,
with
and yes, sir. And sir, what about the F gases? Because actually nowadays we are using too much refrigeration and AC and other appliances. Actually, no one is talking about the F gases there.
right.
Miss, we should capture that or not?
Right, the focus keeps on changing on the different decades actually, man. So now to the reasonable extent, the problem seems to be resolved or taken care, because once they said that this kind of gases are to be replaced, they have been replaced in the phase-wise manner. Some other chemicals are used. So focus is not now there on that particular gases, but certainly that is a continuous process. We have to evolve and find out what other, unless we find some other adverse impacts of certain gases, till that it continues. And
Yes.
once like the plastic, once upon a time it was considered to be the best material, isn't it? It replaced everything.
Yeah.
It replaced iron, it replaced glass, everything. Now we are coming again back to that. This plastic has become the biggest problem now. It is spoiling all our environment. Even our
Have you
is spoiled.
submitted the report and today's report also? No, so tomorrow. My dear participant, have you submitted?
So like this is a continuous process that I mean, nothing is absolute. We have to keep evolving the things as it comes, and see that what best can be done to make our planet worth planet. Yeah, any more questions?
Sir, I'm having a question.
Yeah, please.
Hello.
Yeah,
Sir,
please.
some advertiser also seen on the televisions that AC is providing the pure and unpolluted air. So
Mhm.
how it is so, and really are they providing pure air? ACs. Actually, we are saying that the AC is polluting our air in various ways. But still also some advertises are going on the TVs that the AC providing you a pure and unpolluted air. So is it possible or?
No, this is basically in terms of the two things are there. Like uh, whenever the AC takes air from the outside, it filters that.
Yeah.
So there may be some aerosols along with that might be coming in. So they may affect everything. We are thinking that whatever is coming from the outside is not good, but at the same time it may happen that the whatever is the inside air pollution, that may be the more serious than the outside pollution. So depending upon the locality area one is living, I think that needs to be looked. But this is a marketing strategy by
Yes.
them. So particularly for the children where the infants are there, they try to market their product. And we feel
That
very
means
happy with what.
They are befuddling us, I think, giving on
Yeah,
advertisements.
this is the advertisement trick, and this is how we are influenced by the market. Yes, this is very safe for us.
Okay. Thank you, sir.
Again, anybody would like to ask any question?
I think no more questions are there, sir.
Okay, okay. Okay, so if there are no more questions, I once again thank Dr. Praveen Meshram ji for giving me this opportunity to share my views, my experience with all the faculty, esteemed faculty or different institutes at their places. And I'm sure that together we will be able to make some little bit change in our whole behavior, in our thinking, so that it makes a great efforts towards environmental sustainability. Thank you very much.
Wait, sir, wait. Let's move for a vote of thanks. Hello. Hello.
Yeah, yeah.
Participants, किसे सौंपा गया था vote of thanks?
Yes, sir. Yes. Good evening, sir.
Please.
First of all, I would like to thank Praveen Meshram, sir, for giving me this opportunity to propose the vote of thanks. Participants of the refresher course UGC HRDC, I take this opportunity to thank Dr. S.K. Goyal, sir, who elucidated all of us on the air pollution topics, which included the air pollution sources, hotspots identification, air quality monitoring, circular economy, etc. It was worth attending session, sir. Thank you, sir.